take a look at circumcenter and incenters of triangles. So first we want to take a closer look at the circumcenter, and again that is the point of concurrency for perpendicular bisectors. Now a circumcenter can be found on the inside, on, or outside of a triangle. So as you can see here, the circumcenter is inside when you have an acute triangle. If you have a right triangle, it's going to be actually on a side of that triangle. And then if it is an obtuse triangle, because we have this obtuse angle right here, it is actually going to be on the outside of that triangle. All right, so a few more characteristics of a circumcenter. Of course, we know that it is the point of concurrency for perpendicular bisectors. So these are our perpendicular bisectors here at DF, DE, and DG. So perpendicular bisectors, my pen here, DF, DG, and DE, right here. Hopefully you can see that. And they are perpendicular bisectors because, as we can see, these are right triangles, or right angles right here, and they cut each side in half equally because we can see these congruence marks, that it is dividing each side equally. All right, so those are perpendicular bisectors. And the circumcenter D would make AD equal to BD and equal to CD. So I'm going to write in 4 congruence marks here because it is equidistant from the vertices of the triangle. And now we have radii of the circle. So the radii are segments connecting the vertices of the triangle, and the circumcenter are the radii of a circle circumscribed about a triangle. Quite a bit of information there, but simply put, in green here we have our radii, or we have one radius here. And as you can see, if you look at point D, and it goes, so look at the radii DA, and we can see that that point, or that segment, actually goes from the circumcenter to the edge, and it goes, it touches that circle, all right? And a circumscribed circle is a circle that passes through all the vertices of the polygon here. And so A, B, and C are vertices of this triangle. And as we can see, this circle passes through all of those vertices. And D, DA, DB, and DC are radii of that circle. And circumscribed literally just means to draw around. So quite a bit of information on this slide here. So a little bit more about circumcenters here. We know that it is the point of concurrency for perpendicular bisectors. And it is also equidistant from each vertex of the triangle. So our vertexes for this triangle are A, B, and C. So we can conclude that PA is equal to PB right here, and it's equal to PC. So if you know one of the segments, you know all of them because they are equal. Our circumcenter here is the point P. And let's look at our perpendicular bisectors, because the circumcenter is the point of concurrency, or where the lines intersect, for perpendicular bisectors. Our perpendicular bisectors here are PF, PD, and PE. And we know that they are perpendicular bisectors. So as an example, if we look at PD here, right here, it is perpendicular to side AB, and we know that because we have that right angle here. And it actually cuts AB into half into 2 congruent parts, and we know that by these congruence marks. So PD would be a perpendicular bisector along with PE and PF, because we have these right angles and the congruence marks there. So let's list some more congruent segments here. More congruent segments are AD and DB. So AD right here and DB. Next, we could say that BE is perpendicular to EC, and AF is, did I say perpendicular? If I did, I meant congruent. AF and FC are also congruent as well. So we have those pair of congruent segments there. So let's look at finding the circumcenter of a triangle on the coordinate grid. So we're given these three ordered pairs, P06, O00, and S40, and we want to find the circumcenter of this triangle with the vertices of these ordered pairs. So first we want to find the intersection of two of the triangle's perpendicular bisectors. We only need two to find the circumcenter. So what we do on step 1, the ordered pair 03 is the midpoint of PO. So right here, because the length of PO is 6, and so halfway through, of course, would be at 3. And so that line would be y equals 3. And if we draw a line there, that would be a perpendicular bisector right here. If we want to draw a right angle, we could do that. Next, 20 is the midpoint of OS. If we look here, OS is 4 units, and so the halfway point would be at 2 right here. So we can draw a line there, and that would be at x equals 2. And then we just want to find the point where the perpendicular bisectors intersect. All right, so here, this would be, I'm just going to label these lines, y equals 3 and x equals 2. But where do they intersect? They intersect right here at that ordered pair 2, 3. Therefore, the circumcenter of that triangle is at the point 2, 3. Alright, so for this particular problem, we want to find the measure of BC. And we're given the information that P is the circumcenter. And since P is the circumcenter, that is the point of concurrency, or it is where all of the perpendicular bisectors meet. So that would make PE a perpendicular bisector, because it goes from P to the side, all right, because P is the circumcenter. And that would make BE and EC equal, because if it is a perpendicular bisector, it cuts each side into 2 equal parts. So in order to find BC, first we need to find x. So we could just set up an equation, 13x minus 51 equals 10x minus 33, because they would be equal. So we just use our algebra skills to solve this equation, subtracting 10x, and we're left with 3x minus 51 equals 33, adding 51, 3x equals 18, and last, dividing 3 by 3, x is 6. We are not done because we've only found x, but we just need to plug it back in. So if we plug it in for EC, all right, so EC is 10x minus 33. So that would be 10 times 6 minus 33, which is 60 minus 33. So EC would be 27, but we want BC. We could multiply 27 by 2 because BE should also be 27, but I just want to make sure my x value is correct. So I'm going to plug it in right here because I should get 27. So I'm double checking. 13 times 6 minus 51, that is 78 minus 51, and that does in fact give me 27. So just double checking because they should be equal. And so we could either add 27 plus 27 or multiply 27 times 2. Does not matter, it's the same result. So 27 plus 27 will give me 54. So BC would be 54. So let's take a look at the incenter and that is the point of concurrency for angle bisectors, and it is equidistant from the sides of the triangle. All right, so the point P here would be my incenter. All right, and if it is equidistant from the sides of the triangle, that will make PD equal to PE equal to PF. So I'm going to just write some congruence marks here. PD would be equal to PE, and PF, so, because it is equidistant from the sides of the triangle. All right, so P is my incenter. Let's look at the angle bisectors because it is the point of concurrency for angle bisectors. My angle bisectors here would be PB, PC, and PA. And we know that because right here, this is telling us that these angles are cut into two congruent or two measures of the same angle because we have these congruence marks here. All right, so let's look at some more of our, or list some more of our congruent segments here. We could say that AD is congruent to AF right here. So we have AD and AF because of the angle bisector theorem. And next, BD is congruent to BC. So BD is congruent to, this should actually be BE. So these two would be congruent because of the angle bisector theorem. And then last we have CE is congruent to CF. So right here, 1, 2, 3. So these are all of my congruent segments. P is my incenter. It is the point of concurrency for angle bisectors, but it makes these perpendicular bisectors congruent as well. All right, so let's look at some characteristics of the incenter. So for any triangle, the incenter is always the center of the largest circle inscribed or inside of the triangle. All right, so here we have this circle inside the triangle, and so larger circle inside of the triangle, so D would be the incenter. The circle touches each of the three sides of the triangle in one point. So circle touches the sides. Also, the angle bisector theorem, so let's remember this. It says if a point is on the bisector of a triangle of an angle, then that point is equidistant from the sides of the angle, like point D. So that will make these sides congruent. All right. And then this means that the distance from D to the three sides of the triangle is the radius of the inscribed triangle. So these sides are congruent or equal, and that will make these the radius. So the perpendicular bisectors are also the radii of the circle inscribed inside of the triangle. Okay, so let's look at finding the measure if we know the incenter. So we want to find KI. So KI is this segment right here. I'm trying to draw a straight line. So that is KI right there. So since we know that K is the incenter, remember that it is equidistant from the sides of the triangle. So we can conclude that GK is equal to, use another color, to HK, and it's equal to KI. These are all equal because the incenter is equidistant from the sides. So we can use that information to find X. So let's do that. These two segments are equal, KG and KH, so we could simply set 3x plus 17 equal to 7x minus 31 and just solve for x. More algebra skills. We're left with 17 equals 4x minus 31. Adding 31, that gives me 48 equals 4x. So x is 4. So I divide it by 4. No, x is 12. 48 divided by 4 is 12. So x is 12. We want to find ki. So we could simply plug it into either one of these expressions because, again, since the incenter is equidistant from the sides, we can conclude that KH is congruent to KG is congruent to KI. Alright, so I'm going to plug it in to KG. I could plug it in to KH, doesn't matter, get the same thing. So KG, that would be 3 times 12 plus 17, because KG is here. So that would be 36, 17 plus 17, and that would be 53. So if KG is 53, right? Since KG is congruent to KI, that would make KI 53 as well. So we have found KI. All right, next I would like for you to try this problem on your own. G is the incenter. Okay, so we want to find GD. So go ahead and pause the video and find GD. Remember that the incenter is equidistant from the sides of the triangle. So use that information. So go ahead and pause and try. All right, so hopefully you got it correct. GD is 15. GD is 15. So you would simply set those expressions equal. All right, and you will get x is equal to 11 once you set those expressions equal here. And since GD, GE, and GF are congruent, you could plug it into either GE or GF. We plugged it into GF here. And so if x is 11, 11 plus 4 will give us 15. So since all of those sides are equal, that would make GD 15 as well. So hopefully you got that correct. All right, so we've reached the end of the lesson. I want to thank you for learning with me. So hopefully you understand circumcenter and incenter now. Some related videos are centers of triangles. That gives you an overview of all the centers of triangles, as well as the other two are centroid and orthocenter. All right, so again, thank you for learning with me. If you have not already, please like, comment, share, and subscribe. Thank you for learning with me.